Okay, today we're going to do 8-3, and our objectives are to use trig ratios to find angle measures in right triangles and to solve real-world problems. Okay, first example here. Use the trig ratio cosine A equals 25/5 to determine which angle of the triangle is angle A. Okay, so remember cosine is adjacent over hypotenuse. All right, so let's look at cosine of angle 1. Cosine of angle 1 would be adjacent over hypotenuse. And is that equal to 25 over 20, or 24 over 25? Well, I'm going to do my cross product. And when I do my cross product, I get 35 is not equal to 120. Therefore, that is not equal to angle A. Let's look at angle 2. Cosine of angle 2 is adjacent, 4.8 over hypotenuse. And let's see if that is equal to 24 over 25. Do your cross product. And they are proportional. Therefore, angle 2 is equal to angle A. Okay, same thing. I need to give you the trig ratio. So we're going to have sine 8 over 17. And let's see. That's it. All right, besides you know what sine is. Remember that's opposite over hypotenuse. So the sine of angle 1, opposite of angle 1 is 27. The hypotenuse is 30.6. Is that equal to 8 over 17? Do your cross product. And I get 244 and 8/10, not equal to 459. So let's look at the sine of angle 2. Opposite of angle 2 is 14.4. Hypotenuse is 30.6. Do your cross product. And we get 244 8/10 equals 244 8/10. Therefore, angle 2 is equal to angle A. All right, same thing. I'm going to be quiet, let you do this on your own. After I give you the trig ratio. Okay, if you know the sine, cosine, or tangent of an acute angle measure, you can use the inverse trigonometry functions to find the measure of the angle. Okay, here's the inverse trig functions. If sine A equals x, then the inverse of sine x equals the measurement of angle A. All right, so let's look at this. Okay, first you need to be able to do this on your calculator. So you need to find the inverse. Let me see if I can help you all with this. Okay, on my calculator, what you have to do is you have to hit your second function button and then hit sine, and you get the inverse of sine. All right, so just practice your calculator. You're using the inverse. So the inverse of cosine 87 hundredths is 29.54, and they want you to round to the nearest degree, so that's 30 degrees. The inverse of the sine of 85 hundredths is 58.2, so that rounds to 58 degrees. And the inverse of tangent, 71 hundredths, is 35.4, which is 35 degrees. So when you're using the inverse, you're finding the angle measure, and your answer should be a degree symbol. Okay? All right, so let's look at this. Find the unknown measures, round lengths to the nearest hundredth, and angle measures to the nearest degree. Okay, so what do we need to find here? We need to find measurement of angle R, measurement of angle T, and segment TS. Okay? Well, let's look at this measurement of angle R here. So I have hypotenuse and adjacent. So if I take the inverse cosine, let me back up. Measurement of angle R. So measurement of angle R equals the inverse of cosine. And cosine, remember, is opposite over adjacent. So, whoops, that's not right, guys. Opposite over adjacent is tangent. It's adjacent over hypotenuse. Okay, so adjacent to angle R is 5, hypotenuse is 5.7. So what you need to do is you need to hit your second function button, hit your cosine. You should see this inverse, cosine with the -1, then in parentheses, 5 divided by 5.7 in parentheses, and you should get, rounded to the nearest degree, 29 degrees. And then for measurement of angle T, well, all I need to do is take 90 and minus the 29, and this is approximately because we had to round the 29, and I get 61 degrees. And then for ST, let's see, we can use Pythagorean theorem. Here's your hypotenuse. So take your hypotenuse, solve for ST, and ST is going to be approximately 2.74. Okay, let's do another one like that. On this one, we have to find measurement of angle D, EF, and FD. Okay, well, measurement of angle D, guys, use common sense here. I've got a right triangle, and I'm given one acute angle. All I got to do is take 90 and minus 58. And I get 32 degrees. Okay, EF. EF is this right here. So if this is 58 degrees, I have adjacent. Actually, I have opposite over adjacent. So what I can do is I can take the tangent of 58 degrees equals opposite 14 over, let's use our variable x. So remember, this is where you cancel out that x. So I have the tangent of 58 degrees times x equals 14. Divide both sides by the tangent of 58 degrees. Therefore, x equals 14 divided by the tangent of 58 degrees. And you should get approximately 8.75. And that is your EF. Okay, now we got to find FD. Okay, because EF is approximately, do not use Pythagorean theorem. So we've got hypotenuse over opposite. So let's use sine, opposite, and hypotenuse. So for FD, what you can do is you can take the sine of 58 degrees equals, opposite is 14, over what we're solving for here. So x is going to be 14 divided by the sine of 58 degrees, which is approximately 16.51, and that is your FD. Okay, I'm going to have to stop to make sure we have time.